Deductive reasoning definitions. Deductive reasoning is the process of proving a specific conclusion from one or more general statements. Theorem is a conclusion proved true by deductive reasoning. Examples: our college students have to take math. You are a college student, therefore you have to take math. So starting from all or general statement and make a conclusion to just the specific example, which is you. Second example, the course policy states that work turned in late will be marked down a grade. I turned in my report a day late, so it was marked down from B to C, which is true because the cost policy states for the general guideline and apply to everyone. And I'm one of the specific example. I turn in my report a day late, so then I get the the grade like marked down by one grade from B to C. Describe procedures that are to be applied to numbers. Part A, inductive reasoning. Repeat the procedure for three given numbers. Given the number 4, number 7, number 11, and repeat the procedures as the first procedure, multiply the number by 6. If the number is given to be 4, 4 times 6 is 24. And next, add 8 to the product, which is a result from the previous procedure, which is 24. So we add 24 by 8 to get 32. Next procedure, divide this sum by 2. The sum, which is the result from the previous procedure, in this case is 32. 32 divided by 2 is 16. Next, subtract 4 from the quotient. The quotient is the result from the previous procedure, which is 16. So 16 subtracted by 4 to get 12. And then we're gonna see the summary like from the given number 4 and we get the result as the number 12. Now we're gonna see a couple more examples. The next one, the number is given to be 7. Multiply the number by 6. So 7 times 6, which is 42. And this becomes the product. Now we're gonna add 8 to the product. The product is 42 added by 8, we get 50. And the 50 now, this is called the sum. We divide this sum by 2. So the sum 50 divided by 2 to get 25. And 25 is called the quotient. We're going to subtract 4 from the quotient. So 25 minus 4, that becomes 21. And next we're going to see the relationship of 7 and 21 as a conclusion later on, or it's called the conjecture. The given number 11, multiply the number by 6. So, sorry. So 11 multiplied by 6, which is 66. The 66 is called the product. We're going to add 8 to the product to get 74. And this 74 is called the sum. We're going to divide the sum by 2 to get 37. And next, subtract the quotient, which is 37 by 4 to get 33. And see the relationship of 11 and 33. Based on our observation, 4 becomes 12, 7 becomes 21, 11 becomes 33. It looks like from the given number, we're gonna get the result as the triple of that given number. So the problem asks you to write the conjecture, which is the hypothesis, which is the conclusion based on the observation for the inductive reasoning that relate to the result of this process of the original number. So we can say that the result is the triple of the given number or the original number. Now, next part, we're gonna use the variable n to represent the original number and use in deductive reasoning. This time we're gonna use deductive to prove the conjecture in part A, which means the given number n will give the result as 3 times n or the triple of the original number. Starting with select the number n as the given number n, multiply the number by 6. So 6 multiplied by n to get 6n. Add 8 to the product. So 6n plus 8. Divide this sum by 2. So 6n plus 8 divided by 2. And simplify to get 6n divided by 2 plus 8 divided by 2, which means we have 3n plus 4. Next, subtract 4 from the quotient. After we simplify, the quotient becomes 3n plus 4. So then, for the last procedure, that means we have 3n plus 4 subtracted by 4. After we simplify, we should get 3n, which is the same result as the three examples or the three numbers that we used for part A. So starting with the n as an original number, the result is 3n. So the next part, the question asks, does this agree with your inductive hypothesis? Inductive hypothesis is the conclusion of the inductive reasoning. The conclusion of deductive reasoning is called theorem, which works for all numbers n. Now, the next question, does this agree with your inductive hypothesis? Inductive hypothesis that what we saw in part A, hypothesis or conjecture said the result is triple of the given or the original number. So the answer of this is yes.